Welcome to lesson number 4. Today we're going to talk about the remainder theorem and also the factor theorem. So to begin, we want to use synthetic division to solve this expression, which is going to be x cubed minus 2x squared minus 4, and we're dividing that by x plus 1. So if we're dividing by x plus 1, then we'll have negative 1 here, and x cubed will be 1 minus 2 and minus 4. And since there's no x term, that should actually be 0 and then negative 4. Alright, so first thing we do is carry down that 1, multiply negative 1 by 1, and we're left with negative 1. Negative 2 plus negative 1 will be left with negative 3. Negative 1 times 3 will be left with positive 3. 0 plus 3, we're left with 3. And then negative 1 times 3, left with negative 3. Negative 4 plus negative 3, we're left with negative 7. And that's our remainder. Now, what the remainder theorem tells us is that our remainder is actually equal to p of negative 1, so whatever that factor is there. So if for every value of x, I substitute negative 1, I'm going to end up with negative 1, minus 2, minus 4. Negative 1, negative 2 is negative 3, negative 4 is negative 7. So this is what the remainder theorem tells us, is that if I have x cubed minus 2x squared minus 4, and I divide that by x plus 1, the remainder is going to be equal to p of whatever that value is that we were dividing it. All right, so when px is equal to x cubed minus 2x squared minus 4, and we divide that by x plus 1, the remainder, in this case, if I divide it by x plus 1, it's going to be p of negative 1. And same thing with this second example. You can run through it yourself, but we're just doing the exact same thing that I did up here, and then plugging in whatever remainder, or you'll have your remainder, then plug in whatever value you use to divide by that factor. All right. And so if you want, you can read this bottom section that goes over what the remainder theorem is actually stating. So let's move on to the next example here. Use the remainder theorem to find the remainder when p of x is equal to 6x cubed minus 4x squared plus 8x plus 6. And so we don't actually have to do the synthetic division here. You could check if you wanted, but if I am working with x plus 1, that means p of x is going to be p of negative 1. And that's equal to 6 to the negative 1 cubed minus 4 to the negative 1 squared plus 8 negative 1 plus 6. P of negative 1 is going to equal to negative 6 minus 4 minus 8 plus 6. And that is going to be equal to negative 12. So the remainder theorem tells me that when I'm looking for p of negative 1, that the remainder for this problem would be negative 12. Right, and so we'll do the exact same thing here, but instead of plugging in 2x minus 1, we're going to plug in negative 1/2, just like we had done earlier. And so I'll let you work on that. Next thing, find a if the remainder is 131 when p of x is equal to 2x to the power of 4 minus x cubed minus 8x plus 8, and we divide that by x minus 3. Alright, so what goes here is 2 minus 1, 0, negative a, and positive 8, and 3. So first thing I do is bring down the 2. 2 times 3 is 6. Negative 1 plus 6 is going to be 5. 3 times 5 is 15. Add 15 to 0. I got 15 times 3 is 45. This becomes 45 minus a. 45 minus a times 3, I'm left with 135 minus 3a. 135 plus 8, I'm left with 143 minus 3a. and that is my remainder. But I know that my remainder is actually 131. I know that r is equal to 131. And so if I put this into equation, 131 is equal to 143 minus 3a. 131 aside, I'll get the a over here. I'm going to end up with 3a is equal to 12, and a is equal to 4. That's 131. Now let's use the remainder theorem. So we're going to plug in 3 here. What we should get is an answer of 4 again. So p of 3 is equal to 2 to the power of 4 minus 8, or sorry, not 8, 3 to the power of 3 minus 3a plus 8. And we know that the remainder is equal to 131. Well, not the remainder itself, but we know that, the remainder is 131. That's not the value of a. So 3 to the power of 4, 16 times 162 minus 27 minus 3a plus 8. 131 is equal to 160 minus 27 plus 8. 143 minus 3a. And we're going to do the same thing. I'm going to get 3a over here and subtract 131 from 143. I'll be left with 12, and a is equal to 4 again. Okay, next question. You could probably do this by yourself, but I'll just explain what you'll be doing. Find the coefficients d and c. So we're looking for d and c if the remainder is negative 41 when divided by x plus 3, and the remainder is 74 when divided by x minus 2. So what you're actually solving for is p of negative 3, that's what that tells us, and p of positive 2. And so we would be working with 2 times negative 3 to the power of 4 plus d of negative 3 cubed minus c of negative 3 squared plus 5 times negative 3 minus 8. And we know that p of negative 3 is equal to negative 41, we're told there. And you can solve this pretty easily. And well, I guess I'll do this part. 162 minus 27d, negative 3 cubed, minus 9c, minus 15, minus 8. Since I'm solving for d and c, I'll bring those to the other side, so they're positive. 27d plus 9c is equal to 180 on this side. And I'll divide the divide all these by 9. I'll get 3d plus c is equal to 20. Now this is the first part. The next thing we're going to have to do is plug in p of 2 in. And once we do that into the same expression, so it'll be 2 times 2 to the power of 4 plus d times 2 cubed minus c times 2 squared plus 5 times 2 minus 8. You'll solve this, and we know that this is equal to 74, and I won't do this side, but you're going to get an expression just like 3d plus c. What you're going to have to do is add those together. So it'll be 3d plus c is equal to 20 plus another expression. And you'll add those together and then solve for c and d. So pretty straightforward. Now the last one we're going to look at is the factor theorem. So if I have the binomial x minus a, and that's a factor of the polynomial function p of x, it's only going to be a factor if and only if p of a is equal to 0. Know that a is then a 0 of the polynomial function p of x. So show that x minus 4 is a factor of p of x equal to x squared plus 2x minus 24 by using synthetic division. Alright, so synthetic division, that means that we're dividing by 4, and we're going to be 1 plus 2 minus 24. We can carry down that 1. 1 times 4 is 4, is 6, is 24, and we end up with a remainder of 0. So whenever we have a remainder, that means that whatever number we were using is a factor. And we can find the same thing if we're looking for p of 4. We'll plug that in. 4 squared plus 2 times 4 minus 24. So we hopefully this is going to give us an expression that equals 0. So 16 plus 8 minus 24 is equal to 24 minus 24 is equal to 0. All right, and yeah, that's pretty much the factor theorem. I'll go through I'll go through each one in the first column, and then you can do the bottom one yourself. But write a binomial factor with integral coefficients of the polynomial p of x if p of 3 is equal to 0. Well, that binomial factor would then be x, since it's plus 3 in there, x minus 3. If p of 5 is equal to p of negative 2, and that is equal to 0, determine a second degree factor of the polynomial p of x. Well, if I'm working with p of negative 5, that becomes x minus 5. Negative 2 would be x plus 2. If I multiply these together, since both these are equal to 0, I would just have to expand it. So if I expand it, that gives me x squared plus 2x minus 5x, which would be negative 3x, and negative 5 times 2 is going to give me minus negative 10. And then use the factor theorem to determine which of the following is a factor of 4x cubed minus 16x squared minus x plus 4. So all we're doing is we're plugging negative 2 into this, and we're going to plug positive 1/2 into this. Now whichever one gives us 0 is going to be the one that is a factor. All right, so you can also go ahead and do that one yourself.